Today's video starts on page 12. It is a problem of the day page. I would like you to do these 7 questions, order of operations. Give it your best shot on those ones on the bottom where you're using the numbers 3, 4, 6, and 8 to make a true statement. And on to the next page. Integers. Integers are the set of numbers. And yes, you could use curly brackets here to enclose this set of numbers, all the way from negative infinity all the way up to positive infinity. They keep going and going. Integers greater than 0 are positive integers. Integers less than 0 are negative integers. And the integer 0 is neither positive nor negative. Integers are all the whole numbers and their opposites. Opposites are two integers the same distance from 0 but in opposite directions on the number line. The opposite of negative 3 is positive 3. The opposite of 0, because it is not signed, doesn't have a positive or a negative, does not exist. DNE, or you could say none. There is no opposite of 0. Does not exist. DNE. The opposite of 9 is negative 9. And the opposite of negative 35 is positive 35. For positive 35 and positive 3, you don't have to put the positive signs. I'm going to. You don't have to, though. You could just say 3 and 35. Absolute value. So we have some vocabulary here. The distance a number is from 0 on the number line. Remember, distance is always positive. You can't say that I'm negative 5'4", or that tree is negative 60 feet away. So distance, absolute value, is the distance a number is from 0 on the number line. It's a measurement, so it can't be negative. The absolute value symbol is 2, almost looks like L's on either side of the number line, as you see here. This is the absolute value symbol. They look a little bit longer usually than the number itself. So the absolute value of 7 is 7. How far away is 7 from 0 on the number line? The absolute value of negative 5, how far away is it from 0? Well, it's 5 hops away, so it is absolute value is 5. The absolute value of 0, how far away is 0 from itself? 0 spaces on the number line. And the absolute value of negative 24 is 24. So you can see absolute value is just the number itself that's inside that symbol without any signs on it, positive or negative. Let's write an integer for each situation. 6 degrees Fahrenheit below 0. It says write an integer, so I'm not going to label it. Just writing the number, 6 degrees Fahrenheit below 0. That would be represented by negative 6. A loss of 10 points. That would be represented by negative 10. A deposit, if you're depositing money in your account, that's a positive. Positive 30. Again, no labels, no dollar signs. And a withdrawal, if you're going to withdraw money out of your account, that would be subtracted by the bank. A withdrawal is subtracted or negative 250. Next page. Comparing and ordering integers. To compare and order integers, think of a number line. The farther to the right on the number line is greater. So you probably remember in your first grade or kindergarten class, your teacher had this number line that was taped on your desk, and that's how you learned to count. And as you go to the right, things keep getting bigger. So you know, for instance, that 5 is greater than 3 because it's to the right of 3. Well, that's also true with the negatives. Negative 3 is greater than negative 5 because negative 3 is right of negative 5. So that's still true. As you go to the right, things keep getting larger or bigger. As you go to the left, things get smaller. Just like in your kindergarten class, and you had that number line and say it had a 20 over here and you know it ended on 0, we know that as you go left, so for instance it stopped at 2, that 2 is less than 20. Going left, things get smaller. Going right, things get larger. So in this example, oh, this should be a -2, by the way, -2. Since -2 is to the right of -3 on the number line, -3 is less than -2. So when you're comparing them, in the negatives, the closer the number that is to 0, that's going to be the larger negative number. Therefore, -1 is the largest negative number. Kind of opposite what you think. You would think it would be like a -3 billion something. But -1 is the largest negative number because it's most right, it's closest to 0 on the number line. So as you go to the right, just like in kindergarten, things get larger. Here's some examples. Replace that circle with a less than or greater than to make a true statement. Well, -3 is left of +3, so -3 is less than +3. -2 is right, and it's closer to 0 than -5. -2 is greater than -5. Order the integers 0, 3, -1, -3, and 5 from least to greatest. Least would be -3, then -1, then 0, then 3, +3, and +5 would be the greatest. Replace each circle with a less than or greater than to make a true sentence. -5 is left of 7, so it's less than +7. 0 is actually greater than all the negatives. It's greater than -2. -12 is left of -10 on the number line. -12 is less than -10. Numbers 4, 5, 6, and 7, order those integers from least to greatest. I'm going to leave those for you to do, so you can pause the video now, try those 4 problems, and put those in integers in order from least to greatest. We'll go over that in class. Let's go to the next page. Make sure you answered those questions. So we have a large number line up there. It goes from -10 to +10. It says, where do you begin when locating a number on the number line? So you always start at 0. Always start at 0. What do you call the distance between a number and 0 on the number line? Well, that distance is called the absolute value. Distance. There's the key word, distance. The absolute value of a number is its distance from 0. Letter C, you can see I already filled in here. What is the relationship between 7 and -7? So you may need to pause the video here because I'm not writing this. It's already written here, but you need to fill this in. -7 and 7 both have the same absolute values. They are the same distance from 0. They are in opposite directions. They are what are called opposites. So there's this integer card game that we're going to play in class. And they actually, it's a deck of cards that has positive and negative values in it. What is the value of the sum of the card values shown? Use the counting on method on the provided number line to justify your answer. Okay, so you start at 0, just like it's said up above, letter A. Always start at 0. My first card is a 5. So I'm going to start at 0, and you can either draw it like little hops or jumps over to 5, and I'm going to stop at 5 and draw a line. So that's my first card. Or you can draw it just a little bit faster. It goes a little faster if you just draw an arrow pointing to the right and stopping at 5. The next card says -5. Well, since it's negative, you're going to move to the left. So positive is to the right, and negatives you move to the left. So I need to start at this line that I drew there and count 5 left. 1, 2, 3, 4, 5. Oh, I'm back at 0 now. I'm going to draw a line there. So I went 5 to the left. Now I'm going to go left with my -4. So I'm going to count 4 spaces on the number line. 1, 2, 3, 4. Now I'm at -4. And then I'm going to go right +8. So I'm going to go from that line at -4. 1, 2, 3, 4, 5, 6, 7, 8. And I end up on, what is the final position on the number line? I'm at 4 here. So I'm at +4. What card or combinations of card would you need to get back to 0? In the integer card game, you always want the sum of the cards in your hand to be as close to 0 as possible. So if I'm at 4 right now with this cards, if I added the value of those cards up, 5 and -5, -4 and 8, I get a +4. So to get back to 0, I would need to, to get back to 0, I would need to move to the left 4, so I would need a -4 to get back to 0. Letter C, as you can see, I already filled it in. How should arrows line up when counting on them? They should correspond to a hop or a jump of an integer. They are always pointing in the direction that they move, right for positive, left for negative. So we're using integer cards and we're using number lines to show you this information. Use the number line to answer each of the following. The additive inverse. How far is 7 from 0 and in which direction? Well, 7 is 7 units, right? 7 units to the right. What is the opposite of 7? -7. How far is -7 from 0 and in which direction? Well, -7 is 7 to the left. 7 units to the left. Thinking back to our previous work, how would you use the counting on method to represent the following? While playing the integer card game, the first card selected is 7 and the second card selected is -7. So you would start at 0, and I'm going to show this on the number line. I would start at 0 and I would move 7 to the right. I would start at 0 and count up 7 to the right. Then I would start counting left 7 to end at 0. So if I got a 7 and a -7, the sum of my two cards would be 0. What does this tell us about the sum of 7 and its opposite, -7? Well, 7 and -7 combine to make 0. Letter F, look at the curved arrows that you drew for 7 and -7. Well, I just drew straight arrows. What relationship exists between these two arrows that would support your claim about the sum of 7 and -7? Well, the arrows are both the same distance from 0, 7 and -7, and they have the same absolute value. If you're going to add two things together that have the same absolute value, you're going to get 0. Do you think this will hold true for the sum of any number and its opposite? Yes. Moving in opposite directions brings you back to 0. So opposites add to 0. This little box tells us that for all numbers A, any number A, there is a number -A such that A plus -A equals 0. The additive inverse of a real number is the opposite. So opposite and additive inverse mean the same thing with adding. The additive inverse of a real number is the opposite of that number on the real number line. For example, the opposite of -3 is 3. A number and its additive inverse, so -3's additive inverse is +3. have a sum of 0. Negative 3 plus positive 3 equals 0. So negative 3's additive inverse is 3. 3's additive inverse is negative 3. The sum of any number and its opposite, or its additive inverse, is equal to 0. In class, we're going to play with the integer cards. So it says practice playing this with your partner or your group. We'll do that in class. And the summary of this lesson is that you add positive integers by counting up and add negative integers by counting down. So you add positive integers on a number line by going to the right, counting up, and adding negative integers by going to the left, counting down. An integer plus its opposite, or its additive inverse, sum to 0. Like negative 6 plus 6 will give you 0. The opposite of a number is called the additive inverse because the two numbers' sum is 0. When you add them together, you're going to get 0. And that's it for today's video.